Hi everyone. A very good afternoon from my side. First of all, I would like to thank you for joining us in this webinar series, which is Masterclass on AI. So I'll be your host today. My name is Hubert Fernandez, and I take care of business development and GPU initiatives in E2E networks of Pan India. So as you can see today, we are going to cover like two topics basically. First one is like adopting AI in computer vision and challenges, which will be covered by Mr. Saurabh, who is a co-founder CTO at our AI.ai. And the second topic will be video analytics on NVIDIA A100, which will be covered by Mr. Pallav Maji who's a senior solution architect at NVIDIA. In between, if you guys have any queries or questions, you can always raise your query in the Q&A section. Once the session is completed, we'll take all the queries together. So yes, so let's get started. Saurabh, you can just share your screen and take us through your presentation. Thank you.
Yeah. Hey guys. Uh, yeah.
Saurabh, are you able to share yeah, we can see. Great.
Hello. Can you see my screen?
Yes, Saurabh, we can see your
Yeah.
screen.
So, hello everyone. Today I'm going to talk about adaptation of AI and its challenges. I'm Saurabh from RI.ai. So before we start jumping into the topic, may I know who all have a background of uh, AI and AI and its use cases and the advancement in AI? Great, great. So I guess you might also know that since the research in AI has been booming since past 5 years, but we have seen a lot of great things. We have seen a lot of great things in AI. In the sense that we have seen amazing chatbots that help a lot of businesses. We have seen things like autonomous cars. We have seen a wide range of great algorithms like AlphaGo, which beat uh, Go world champion 4:1. And we have also seen things like GPT-3, GPT-2, which can generate text in a way that is so much close to how humans basically create articles, make articles, and things like that. So we have seen a lot of advancement in AI and AI research part. We have seen like a lot of things in terms of security, equality, and everything has been incorporated in AI research. But in these advancement, we have seen that the adaptation in businesses is it's not as fast as how AI is growing rapidly in research. So the main there are a couple of reasons why this is the problem. But before that, there is a statistic saying that there are more than 932 startups that were funded uh, in US itself in 2019 that are AI related. So not that I'm not saying that AI is not advancing in businesses, but it's catching up slowly. So, what are the main challenges? So, the main challenges in adaptation of AI is actually very basic. The most, uh, the biggest reason is the expectation of people and what AI can do. Of course, AI has a lot of possibilities for businesses, but when it comes to actually deploying, actually using AI, it becomes very difficult as AI is heavily data dependent. So when business owners consume vast amount of information that contains like promises about how good AI is, their expectations goes out of the world. This makes businesses very ignorant about the challenges that come along with adaptation of AI, like lack of data, lack of compute at the business's disposal, lack of hires, lack of experts that they have on the team. Uh, this sets a confusion on what AI solution businesses actually need. So because of this, they jump onto the AI adaptation wheel without knowing actually what exactly needs to be done in order. What are the prerequisites of uh, adopting AI into their businesses? Apart from that, the another biggest challenge is business use case. We have seen that AI research is booming in terms of autonomous vehicles. We have seen in medical imagery. We have seen AI used in drug discovery and things like that. But not all of these fields come into are very research oriented. So for businesses, small and medium businesses, it becomes difficult for them to prioritize which common problem to solve using AI. So th- uh, so and along with that, if you see the return on investment on putting so much money in terms of research in AI and things like that, the return of investment is pretty low. So in recent study, we have seen that DeepMind, Google backed company, research company, had more than $600 million of losses. So losses in terms of losses in the company. So we have seen that despite the gain in AI, despite the gain in AI research, the adaptation and the real life implementation of these research is getting backed off due to high costs and a lot of different factors, in the sense that expectations, realities, and things like that. So along with that, as I mentioned, doing getting on to integrating AI into your business is very challenging, in the sense that you need to have like a specific budget in order to the budget for any of these uh, budget of any of these uh, challenges that you're trying to solve using AI is of course not is very big. If you have seen the AlphaGo documentary, the entire algorithm consumed more than 1035 CPUs and more than 500 GPUs in order to just train that kind of algorithm. And not all businesses have these resources to train a model at this length. So, according to Harvard Business Review, more than 40% executives say that their expenses, the expense of AI, in the sense that all the infrastructure as well as the hires and the expert, is way too expensive than the amount that they will cash out at the end of the product. So apart from that, many of small businesses depend on credits. So once the credits once the credits stop, once their credits vanishes, they incur overhead expense, a lot more overhead expense. So these are the few challenges that early stage enterprises or businesses might face when they are starting off in adaptation of AI and in their company, or in their division, or things like that. So we have talked about the challenges, but what are the solutions? So the solutions are pretty like pretty uh, it's something that you have to think a lot, and you have to manage everything, manage the reality, manage the expectations, manage the budget, manage the use cases, and things like that. We discussed about expectation and reality. So in order to manage these expectations and reality, we the first step that can be taken by any division or any startup that is venturing into AI and want to adopt AI is to basically look at the possibilities of what exactly can be done by AI, by the help of AI, and what cannot be done by the help of AI. There are a lot of use cases wherein you don't require AI, but you still add AI just to have that AI built with AI or made with AI tag. So there are a lot of things that come into play when it comes to making a blueprint of what all solutions that you want to use in AI, what are the use cases that you want to align your business towards, and things like that. Coming on to business use case. So once you have the blueprint, once you know what all you can solve using AI, and what all things you can solve without AI, you basically have a blueprint of what exactly needs to be done. So there are a lot of places, lot of market businesses fields wherein AI is being used extensively, in recommendations, in automations, in threat detection, in surveillance, and many other fields. And these are the places that can be that are that can be a that can have a bigger future, bigger market by using AI. These markets are helped using AI and users of AI. In talking about in terms of budget constraints, we know that, like, one of the possible solution, one of the best solution for when you have a small budget is mostly outsourcing most of your AI projects, or using managed services to carry out most of your AI workload, instead of building it everything from scratch in house. Along with that, we know that there is an infrastructural cost associated with any kind of AI research or AI adoption, AI engineering. So these are enterprise vendors, softwares, cloud providers like E2E networks, AWS, Google Cloud. These all provide ready to go AI services to which basically curb all your infrastructural costs. So these are the basic solutions that can be these are the basic solutions that can be used to overcome the challenges that were discussed. Along with that, the other big challenge that might be faced would be the data and its collection. So data collection, since there are a lot of laws against data collection, data privacy, and things like that, it becomes difficult for small and medium enterprises to basically collect data from the users and train their models and gain that kind of the level of superiority that big tech companies have. So it is always better. So since it is always better to start off with managed services, and as and when you have the data and the specialty people in your team to basically scale up and build build those models in house, you basically do that once you have the data. So these are all the solutions that I thought could be like that are there. I mean, these are the challenges that we faced while starting up ri.ai. So and I thought it would be great to share these insights with every one of you, since uh, AI is the future, and it's the present and the future. So yeah. So something about RI. So RI is a intelligence. RI is a video intelligence platform solution for enterprises to monitor standard operating procedures to ensure quality control and accelerate real time decision making for FNB manufacturing and real estate. So we basically we use computer vision to monitor different standard operating procedures for cloud kitchens, for manufacturing units, for real estate, housing projects, and places like that, wherein from CCTV camera we uh, use that data which is just getting stored onto hard drives, and make and give out insightful reports, insightful analytics to the business owner, to the homeowner, to the manufacturing unit manager, so that this helps them to drive their this helps them to evaluate get like evaluate their progress in quantifiable measures, rather than just looking at, okay, this is done, this is not done, and things like that. uh,
Hello, Saurabh. Can you hear us?
yeah, yeah.
Okay.
Can you see my screen?
Yes,
I
yes, we
thought
can.
my internet went off first. Yeah.
Yes.
So yeah, that's all about it. That's yeah. So
So
do you have any questions? Anything?
yes, please send your questions in Q&A section. Saurabh, we have one question from Nagendra. Uh, is this to monitor the work being done?
So regarding RI, so work being done in the sense that in terms of there are certain standard operating procedures that define a specific task. So that comprise a specific task. So we monitor all these standard operating procedures of enterprise, and we track those actions, track those SOPs, and tell and give out a report saying that give out a detailed report on what was the duration of how much time did it take to do the entire task, or what was the frequency of this task being done, and things like that.
Okay, I hope Nagen you got. So Nagen has one more query.
So we basically use CNNs for most of our projects, but we are also branching out into a new architecture, that is transformers architecture for attention based architecture for computer vision. So this is the extremely new kind of architecture that we are trying to venture into, as we feel that like we have seen initial tests in terms of how transformers can give a substantial boost in NLP use cases. Apart from that, we have also seen that transformers are being used in many of the GAN related research and GAN related projects. So using transformers for computer vision purposes is also something that we are looking in forward to. So we might do that. uh, answering the follow up to Nagendra, we do provide regular real time reports onto our dashboard. But apart from that, we have like a daily, weekly, and monthly email blast sent to the manager or the point of contact regarding the reports of the week, of the day, and of the month. Uh, yeah, sure, Ria. RI is so basically RI is a video intelligence solution for monitoring all your SOPs, all your basically things that are very essential to your businesses. Like suppose you own a cloud kitchen. So the most important thing for a cloud kitchen is of course their hygiene and their order, if their order is being if their customer's order is being packed correctly or not. So we basically monitor their actions, we basically monitor their standard operating procedures. Like suppose you are making a momo, so there are it basically making of the entire momo is divided into say x number of parts, 4 steps. So we basically monitor these 4 steps and give out how accurate, if all the steps are being followed or not. Apart from that, we also provide like customer demographics, things like customer demographic, customer insights, how many people are entering, how many people are entering your dine-in, how many people are entering your kitchen, how many authorized people are entering your kitchen, and things like that. So basically, we provide a lot of customizability. We provide a lot of uh, like standard packages wherein you can monitor if the person is wearing PP kit, safety equipment, if they are having like if they are wearing proper uniform or not, and things like that.
Hey, thanks Saurabh for your for the great session actually, and answering all the queries for Ria, Nagens and all. So guys, if you have some more queries, you can obviously post it in. We'll take in the last actually. So now I would like to invite Mr. Pallab Maji, Senior Solution Architect, Deep Learning at NVIDIA, to discuss more on about video analytics on NVIDIA A100. So Pallab, you can just share your screen.
Hey, thanks, Robert, and thanks, Saurabh, for the wonderful opening. That gives me a lot of pointers to actually start with. You have laid down the stage very well. Thank you so much for that. Okay, let me start by presenting my screen, and let me know when you can see my screen.
Yes, Pallab, we can see your screen.
You can see my screen.
Yes.
Excellent. So, hello and welcome everyone to this session. I'll be mostly talking about our newer Ampere architecture and the A100 GPUs which are available right now for you to try in E2E Cloud as well, and how they have been instrumental in getting the throughput and the latency and overcoming some of the challenges that sort of talked about in terms of the hardware and the throughput requirement in real time deployment of many of these applications, right? So so with that, let me give you at the start that what this new A100 GPU is all about. So this new A100 GPU is basically a GPU with a lot of new features, primarily some of them hardware, some of them specifically designed to actually accelerate the workflow of deep learning and machine learning workloads. And with that, we basically for inference as well as for training workloads, we see significant amount of boost compared to our previous generation.
So, Palab, sorry
Now,
to interrupt you. Your voice is breaking in between actually a little bit.
okay, just give me a minute. Am I audible?
Yeah, it's better now.
It's better. Awesome. Okay. So, so primarily when we talk about this
हेलो,
newer,
हाँ
hello,
इसका नंबर भेजना मेरे को। ये जो अभी तेरा नंबर है, ये
I
नंबर आया
request
ना
everybody
एयरटेल
if
वाला,
you can
वो
kindly
भेजना मेरे
go
को।
on mute, please.
कौन बोलेगा तेरे साथ ऐसे? हाँ
Thank you. So when we talk about these newer architectures, we basically not only concentrate on the training, but also on the inferencing workloads as well. And we see a significant improvement in the over our previous generation. And let's revisit that. What are those features and what are those factors which are actually helping us do that? So the first thing first, we all know that a traditional machine learning or deep learning application uses a lot of this matrix multiplication operations, and this matrix multiplication operations have an atomic function which is called as fused multiplication and accumulation, or also known as multiplication and accumulation units. So so primarily because of these newer tensor cores, which was designed in our previous generation of Volta GPUs, we saw an improvement in many of the deep learning accelerations in terms of training as well as inferencing workloads. But what we also found out was that with this newer tensor cores, we saw that there was a lot of discussions and lot of research that went on in this mixed precision training, where we found out that reduction in the precision during the training and during the training of deeper networks does not get affected so much if we reduce the precision of the number system. But if we reduce the range of the number system, then it gets affected heavily. And there are plenty of literature which has been done on this, and then automated mixed precision, the whole concept of training on AP32 and AP16 together came into the picture with the newer tensor cores and so on. So we all know about those advancements, right? And that was last generation. In the newer generation, what we did was we came up with this concept of taking the best of both worlds. So what we did was from AP16, we found out that a precision of 10 bits is good enough, but a range of 5 bit is just not good enough to for many of the layers. Not for all layers, but for many of the layers, it does not work that well. So that's why what we did was we kept the range of FP32, and we took the precision of FP16 and merged it together, and we formulated this TF32, which is going to help us in reduction both in terms of memory as well as in the computational units as well, right? So that is the first type of advantage that we get. And with this newer A100 GPUs, you get this out of the box, and we see with this reduction in the precision, there is no loss in the training accuracy as well. We have tested it across different networks with different data sets, and it is being used right now in many of the existing workloads, and it is working out of the box very well. So that's the first thing that we did. The second thing on the on the tensor cores is that now we have a bigger tensor cores compared to that we had in the Volta generation. So now, right now the amount of processing that we can do on a single tensor core is quite is much more. So apart from supporting FP16 and FP32 and Intel, we are also supporting TensorFloat 32 and bfloat 16 as well as additional number representation. The next thing what we did was we often found out that when we have these bigger GPUs with larger frame buffers, and they were really very good while we were training with them, because training workloads are almost 1.75 or around 2x more computationally expensive because of the whole backpropagation process compared to the inference workload. In inference workload, we just do a forward pass, right? And many of the times what happens, that's why we have separate categories for training and separate categories for inferencing workloads. But what we often saw with our V100 GPUs is that when you do inferencing on these V100 GPUs, a majority part of this GPU often remains unutilized because of the inferencing workload that is not using the entirety of the GPUs, and that is some amount of wastage that many of our customers in their workloads found out. So what we did was we came up with this whole concept of taking one GPU and then allowing the user to break it into smaller GPUs on its own. And when we say about breaking them into smaller GPUs, we are not talking about just partitioning the GPUs through software, but there is a hardware isolation that is being created, and these independent instances, they work as an independent GPU on their own. So it will be so you can take one single A100 GPU and you can break it into 7 smaller instances of different profiles, and you can use them for different applications. So be it say for example, you can break the entire GPU into 3 parts, where you have a larger chunk where you are doing a training workload, and then 2 smaller chunks where you do 2 different model inferencing because of the workload. So you have the choice of isolating and segregating the segregating the GPUs and partitioning the GPUs based on your workloads as well. The third and one of the most important factor is the structural sparsity. So we all know that the deeper the network goes, the sparser the activation functions become, right? And because these activation functions become sparse, we waste a lot of computation, because we do 0 multiplied by something, and this computation is basically wastage of power as well as computational time. We try to handle in literature, if you see, there were a lot of different methods in which we try to handle sparsity. But right now, with this newer matrix array multiplication units, we have this option of converting the sparse matrices into dense matrices, and then basically getting the advantage on the hardware level, then handling them on the software level, which is comparatively a little bit slower than doing it on the hardware acceleration units. So these kind of advancements, specifically keeping in mind developing for deep learning and machine learning applications, those hardware components have been designed and developed by us and put it to in our newer architecture, which we call it as Ampere architecture. So when we bring all these different acceleration components together, and in a unified nutshell, if we do some kind of benchmarking, then this is the kind of results that we see. Here I have taken an example of a BERT model, which is which is again a transformer-based model for natural language processing. And here, so here, if we basically talk about V100s versus A100s, you can see that over our previous generation, we are from perspective of training, we have got around 6x of improvement compared to FP32 training out of the box when we do it on TensorFlow without any loss in accuracy. Compared to inference, again, we are doing as good as seven V100 systems. So if we just break the entire GPU into seven smaller instances, one GPU is performing computationally as much as a single V100, the power of a single V100. So that's the kind of scale up and the kind of acceleration that we are talking about when we move from one generation to the next generation. And this is not only in one field. If we see from fields, be it HPC, be it deep learning, be it data analytics, or be it other ML workloads, we see this completely across the board, where we see much better performance with respect to our previous generation on HPC workloads, which are specifically targeting FP64 precision, as well as in many of these deep learning leaderboards like MLPerf, which and TPCC X BB challenges for data analytics. If you see, we do quite well across different workloads as well. So, say for example, for computer vision, if we take ResNet, Max RCNN, and all these different type of models, compared to the previous version, we do we are scaling quite better. Almost 3x of speed up is what we are getting compared to different compared to our previous V100 series. And this is across NLP, be it text to speech, be it recommender systems, or be it speech recognition or computer vision workload across different models. Here I have put in some of these models, but there are much more benchmarks that are available in our website. I have put in the link as well. You can go and look at it later on as well. So now with these hardware components and these kind of acceleration, how do we basically work with the computer vision pipeline? So a typical computer vision pipeline to work with, we basically have a lot of pre-trained models. So we have a software hub, which we call it as NGC. So if you go to ngc.nvidia.com, you can see that all these pre-trained models and Docker containers and model training scripts are housed over there, free to use for anyone. These works very well, and they have been tuned to work very well on NVIDIA GPUs. You can download these pre-trained models and these containers, get your own data, and use a toolkit which is called as transfer learning toolkit. To without even writing a code, you can actually develop a lot of these pre-trained, develop and fine-tune over these pre-trained models and fine-tune them for your application. So the entire framework of using the pre-trained model to train with your data, and then to prune and reduce the complexity, computational complexity of the model, but then retrain and get the accuracy back, and then optimize it for latency and throughput. This entire pipeline is very nicely stitched inside this toolkit, and you can get the advantage of quantization aware training, automated mixed precision, and the goodness of the A100 architecture and the acceleration components that we talked about, all these being optimized and put together into this toolkit together. So if you use this, you fine tune these pre-trained models for your application and generate this output model. Now, to deploy this output model at scale, you require, be it on the edge or be it on the server, you often require a system where the camera is streaming in the data from different sources or different parts of a shop floor, say for example. And those streams can be in raw or TSP format, and then you need to basically decode them. And after decoding, you need to run these models on top of them, probably do some kind of tracking, and then extract some intelligence out of it, and probably connect to a IoT server somewhere in cloud or on-prem, where you have a nice dashboard to visualize this work analytics outputs, right? So, so this entire pipeline, we have deep stream, which can help you in deploying them. And say, for example, if you have a model which you want to deploy on the cloud with an API, so you need to serve then those kind of models. So Triton is another software stack which can help you in deploy these models onto the NVIDIA hardware in the cloud, and then you can write your own API calls through C++ or Python APIs. There is a client library. You can develop that client code. You can start querying your model, which is running in the server, which is deployed, and then you get the goodness of load balancing, auto scaling, and also scaling it across different GPUs for a better load balance. So all these are packed together inside one SDK, which we call it as Metropolis. And this basically gives you the end-to-end deep learning workflow for intelligent video analytics pipeline. So we try to bring in the hardware and the acceleration in the hardware. But at the same point of time, having good hardware is just not enough. We understand that. The concept is that you need to have a good software stack, which with ease any developer can actually take advantage of this acceleration and can replicate easily in their workloads, just not in some workloads that we are running in our labs internally, but it should be applicable to wider audience across different streams and across different use cases, and can be replicated for your workloads as well. So with help of these particular pipeline and with help of these hardware features, we basically developed an application. This is an application we developed for social distancing. And here what we do is we detect people, we track them, and we also try to find out that what is so we put a circle around the person to make a 3 meter of radius, such that when two circles overlap, we basically understand that those two people are very close to each other and they are not maintaining that 3 meter of distance between them, or it is basically parameterized. And then you can have this kind of an analytics running on an IoT server somewhere in the cloud. So how does this pipeline look like? So here, as you can see, it has been trained with a pre-trained model called as PeopleNet. This model is available in NGC. You can download this. The training script is also available over there, and that will give you a people detection model. DeepStream comes with some existing tracking units like. There's a deep learning tracker which has been developed internally. It is free for you to use. There is also KLT and IOU based trackers with which you can actually track these people. And once you track these people, then you create that boundary, you basically can do this kind of dashboard to analyze whether there are any people who are not conforming to the social distancing measures inside a particular premise or not. So this is a very simple application that we develop, but it showcases the different aspects of computer vision, starting from object detection, which is been modified to do people detection, then tracking as well, and then having some rule-based classification to do to extract out anomalies inside a particular pipeline. So with this particularly, I so I just want to summarize that starting from training to building the pipeline to deployment, in all these features, to take them onto a production level scale, you basically need a very good and a strong combination of hardware features supported by good software stacks as well. And with these two combination only, you can basically develop an IVA pipeline, which you can then deploy onto a solution for a product. So with this, I thank you all for joining today. Uh, you can connect with me over Twitter, LinkedIn, or you can drop me an email as well. And I would, at this point of time, let me see if there are any questions.
So, hi everyone. If you all have any queries, you can just post in Q&A section and we'll take the questions. So, Pallab, there is one question actually. This one, I think you, since you have done benchmarking and testing, you can also answer. Nagin wants to know, like, compared to previous GPU offering from NVIDIA, like, I think he wants to know comparison between V100 and A100 GPUs actually. So, if you can just brief him on that part.
So from V100 to A100, as we see, we get a large amount of boost, both in training as well as in deployment as well. So again, it completely depends on the kind of networks as well. Say, for example, if you want to really get the advantage of structural sparsity, then a deeper network is required to test it. Right. If you have a shallow network, then the sparsity really does not, that feature of sparsity and the gain that you get out of sparsity does not really come into the picture. So, say, for example, if you're just training a very old or a very small network, testing out with MNIST or CIFAR 10 dataset with couple of layers or three, four layers of convolutions, there you will really not see any benefit. But if you talk about these networks which are being used in real applications like BERT or say GPT, uh, or even the various transformers models like Distilber, XLM, Robota, Albert, all these different type of models for NLP. Or even if you take examples like Masterclass CNN for instant segmentation, SSD, YOLO V4, V3 for object detection, UNet for semantic segmentation. All these different type of networks, they are really very really very deep networks and very computationally complex. Now, when you take these kind of networks and put them in side-by-side comparison with P100s, there you really see the effect of these hardware and these software components being used to its fullest. And that's where you see these gains. So you get gains around 3x times in terms of training performance improvement as well in many of these deeper networks. When we combine all these tensor cores, the newer TF32, the structural fast sparsity, and all these things, when we combine them together, the unified acceleration is quite good over previous generation.
Okay, Pallab, thanks. I think that would surely answer Nagin's question. So we'll just wait for if any other query is there. Yeah, so I think there are no other queries. So I think then when we will end this session actually. So first of all, yeah, thanks Pallab for your very knowledgeable session, and also a very much thank you to Saurabh and all the attendees who attended this session and made it a successful webinar. Uh, before ending, I would like to say that if you guys, while registration, if you have added, if you want to take a trial of 800, you have opted for that option, we will definitely provide you the trial. In case you have missed it or you have not applied, you can just go to e2enetworks.com and request for a test drive, and we'll reach out to you and discuss the use case, and we will be happy to provide you a free trial of 800 so that you can do the testing of it for your current use case. That's it from my side. Once again, thank you everyone for joining this webinar, and special thanks to Saurabh and Pallab. Thanks and have a nice weekend. Thank you guys.
Thank you, everyone. Really appreciate your time, and I enjoyed the session a lot. Thank you so much for inviting.
Thank you.